using the graph of y equals cos x, sketch the graph of y equals 1 over cos x, which is sec x. So sec x is 1 over cos x. It's the reciprocal of cos x. So we're going to draw the graph of cos x and then use what we know about sketching reciprocal functions to sketch sec x. Okay, and we're going to do that on an interval between minus 2 pi and 2 pi. So cos, I'm going to do, it's not going to be the most even thing in the world, but basically cos starts from a maximum and then it kind of does a wave, and if we're doing 2 of that, it'll be something like that, right? So we want to draw it from minus 2 pi to 2 pi, so that means the y-axis must be here. We know the principal axis splits it in half, so it looks like that. The x-axis running along there, and put some, it's 0 obviously, so this is going to be 2 pi. Here, this is going to be minus 2 pi. This we know is 1. Here we know is minus 1. And then we can say, well, if this must be pi, so this must be minus pi, and so on. I don't think I need a lot more than that. So we could put the other ones in between, but I don't think it's necessary really. Now, this is cos x. So if we want to draw sec x, we need to do what we know about reciprocals. Now, the first thing, remember, whenever you get a 0 on the function, the reciprocal function will be undefined, because 1 divided by 0 gives you an undefined result. So you can see a 0 here, 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 and here. So you're going to have asymptote, a vertical asymptote at all of those places. So let's draw those in. There's going to be another one there. Here. Okay, so they're a bit wobbly, but they are 4 vertical asymptotes, right? The next bit, well, if we think about when cosine x is 1 or minus 1, just think, well, 1 over 1 equals 1. So wherever cosine is 1, then sec will also be 1. So that happens here and here and here, so they're going to be in the same place there. And also when cosine is minus 1, well, that happens here and here, right? So we know we're going through these points, right? And then you just have to really consider the behavior up between the asymptotes. So if we start here, right, so think about this. This cos is positive all the way in here, so sec is always going to be positive. We know it starts from here. And then if you think about all the way here, we're dividing by, so this number's 1, we're dividing by less than 1. Remember, you take the output of cos x, which is here 1, and always getting less than 1 and going towards 0. So when we're dividing by something just bigger than 0, remember that gets you a lot. So we're going to be up here. That's what the asymptotic behavior is all about. And then that's just going to happen gradually. So whenever we divide by 1, we're going to just get 1, and then we divide by less than 1, we're going to get a bit more, and we divide by a lot less than 1, we're going to get a lot more. So it's going to go like this. So that's the first bit, and then if you consider this, well, that's going to happen 2 places here. So when we divide by not much here, we're going to get a lot. When we divide by not much here, we're going to get a lot, but it's all negative. When I say a lot, I mean a very large negative number, and it's going to start from minus 1. So this function is going to go here to that asymptote, and then it's going to come around to that maximum, and then go to the other asymptote like that. Okay, so then we go on this asymptote, and it's just going to happen here in the same way. Something like that, and then it's going to happen on the other side as well, and then it's going to, this area here is going to look exactly the same as this, so down to there and around, And we've just got one more bit, which is this asymptote here. So we're going to come like this. Like that. Okay, so it's not necessarily obvious because my asymptotes look exactly the same as the actual function. It's difficult to know what's the secx and what isn't. But basically, this line here is y equals sec x. So all of this is sec x, and this, and this, and this, and this. And obviously the asymptote isn't actually part of the line, but it certainly is a very important. If you didn't have the asymptotes, it would be very difficult to draw the function. So they are a crucial part of a sketch.